Alright, in that what we have, we've been applying trigonometry on right triangles in many questions you've seen. Every time we had a triangle was a right triangle. Now it's a kind of new thing that we're going to apply even on non-right triangle. Because in the right triangle, say this is the right triangle, so you have hypotenuse, adjacent and opposite. And that's what you assume in each of the 6 trigonometric ratios. But what if, let's say, you have this kind of triangle, which is a scalene, isosceles, or any kind of triangle, which doesn't really has a right angle in that. So there is no hypotenuse in this, right? So you can't define any adjacent or opposite also just because there is no hypotenuse in this. So for that type of questions, we have to apply either sine rule or cosine rule, whichever is suitable. So let's begin with the sine rule first of all. Sine rule is this thing. Before we understand this, let me tell you one thing. If you have a triangle ABC, the vertices are given with the capital letters, right? Capital A, capital B, capital C. So if suppose this angle is capital A, this angle is A, the vertex is A or angle is A, the side exactly opposite to this angle A will be small a. Okay, notice this side has been represented as a small a. Similarly, as you notice, suppose this is the angle B, we have got this is the angle B. So opposite side to that is small b, and also you have suppose angle C here at this end. The side which is just exactly opposite to the angle C will be small c. It's not only ABC, anything like if suppose it's PQR, for example, let's say if it's given to you as a triangle, it's a PQR triangle, PQR. So obviously the side which is opposite to the angle P will be a small p. This is the small q, this is smaller. That order you must not forget, otherwise it will go wrong. So we have a question, like we have a formula. You can either say, obviously in this formula, A, B, C at the top, they are the sides, and capital A, capital B, capital C are the angles. So either you can apply this formula, or even this, you can reverse, you can write upside down. They both are equal things, same things. Either of them is applicable. Now how do we implement that? A over sine A, B over sine B. There are three sides you see. There are two sides, LHS and RHS. But even if there are three sides, we solve them by taking two at once. So it's still the kind of simple equation. Like first we may take these two together. Later on we can take these two together, or even we can take A and C together. It depends upon the situation. Let's take a quick example here, then it will be clear to you. They give you one triangle, suppose, and they ask you, one second, I'll show you the question. One second. This is the question, right? They're given two angles in this. Even if you want to get the third angle, you can get, that will be about 80 degree according to the angle sum property. However, it doesn't make sense, like if you want to apply any of the 6 trigonometric ratios, sine equals opposite over hypotenuse or others, that won't be applicable here, right? So we can't really apply any of the trigonometric ratio in this particular situation. So let's do one thing. We just rename it A, B, C. This is a triangle ABC. What we have to get, we need to figure out this x, they just said. To get the value of x. So what is 12? Can you just tell me in the symbol form what exactly 12 is? Whether it's small a, small b, or small c? Correct. And this is a small b. That's the first thing we have. And I think that's sufficient. By sine rule. The formula we discussed was A over sine A, B over sine B, C over sine C. Now it's useless to take the third side C over sine C, so that's sufficient if you only take this much. So we can just write taking this much only. If we have to deal with that C, we could have taken that. But right now we are okay with this. A over sine A is equal to B over sine B. So the A is what? A is 12. In corresponding angle, A is given to you as 60 degree. Similarly, the B we have to figure out, and we don't know what is, okay, this is sine, angle B is given sine 40 degree. Sine of B degree is sine of 40 degree in fact. And that's how we got an expression, and only one variable is there in that x. So we can easily do that. We can bring sine 40 to this side. 12 times sine 40 degree over sine 60 degree. That's equivalent to x. We can use a calculator for now. 12 times sine 40 over sine 60. I'm directly putting it into the calculator. I get 8.906. So it's approximately 8.9. The unit given to you was centimeter. So we keep the answer into centimeters. That's it. Okay. That's the answer. Now you may tell me if you have any doubt in the question.
No.
Alright, so that's what the sine rule. Would you like to try one question of this kind?
Sure.
Okay. Okay, just try to get the value of A now.
$7.7.
Right, correct. Okay, let's take another example where they given something. One second, I'll show you. Look at this question. This question has given you two angles and one side is given to you and other side we have to figure out. If you want to rename it, let's rename it as A, B, C. And you know the formula by sine rule. We have A over sine A equals B over sine B equals C over sine C. Now you are given, see, this is opposite to the angle C, so that's why it's small c. This is opposite to the angle B, that's why it's small b. Now, okay, so even if you just try to see what all are the values given to you, you are given, okay, small b you need to deal with, angle B is given to you, angle A is given to you, and the side C is given to you. Just like in the previous question, we've taken two sides, two fractions we have to keep together. Now what do you think? Which two fractions you would keep together?
I don't know.
See, right now we have to actually get the this B, but we are given the we have to get B, small b. So small b is given and capital B is given, so that's perfect. This is useful, right?
Yeah.
But now if you talk about, we are given side C, this side is given to you, but they haven't given you the angle C here. It's better if you could figure out the angle C, then we can use these two. So B will only be unknown in that, and we'll be able to solve that. So yeah, we can easily get that actually. We can get that angle C very easily because we can apply angle sum theorem in this. sum of all three angles is equal to 180 degree. So we can just subtract from it and we'll get the answer. So 180, it's I think 60, yeah, 120 degree. Let me check
Hmm.
again. Yeah, it's 120 degree. Yeah, so once we got angle C, that's perfect. So I think these two will work. We take that, taking B over sine B is equal to C over sine C. Now only angle, sorry, the side B is missing that we have to figure out. Rest of the terms like capital B, capital C, and small c are given in this. So that will be easier for us to figure out. Sine B, angle B is given to you as 35 degree. Side C we don't know. Sorry, we are given actually. This is 9. Okay, 9. And angle C is also given to you. Angle C we just have figured out as 120 degree. We bring sine 35 to the other side into multiplication. We have sine 120 at the bottom. You can use the calculator now to get its value. 1 second. It gives you 5.96 approximately. You can also round it off if you want. So it will be approximately 6 if you just round it off. So 6, and what's the unit? Millimeters. We just say it's millimeters.
Hmm.
That's it in the question. So this is the only variation they give, that they might give you a missing angle. Like they give you the corresponding side, but they don't give you the angle. So it's really easy to get a third angle if the two angles are already given to you.
Hmm.
Okay. Yeah. All right. That's one of the question. Let's have another question. It's a combination of a question. Let me show you first. I'll show you how it's given. It's a little tricky, but it's still easy. Let me show you. That's a question given to you. First, you may think about it. If you understand, otherwise, I'll tell you that.
Hmm.
Are you trying it, or should I explain it?
I'm trying it.
Okay.
is it 5.1?
5.1. Actually, don't have the answer, but I guess it's correct according to the dimension that you told. What exactly did you do? First of all, which value you find out?
First of all, wait, can you
Okay,
use
I'll just label. Yeah, 1 second. Okay, right.
so can you use like C and A?
C and A for the first triangle, for the triangle ABC, right?
Yeah.
Okay, so if you're using A and C, um, I don't think so. Instead of getting that, you can do one thing. See, right now we are okay, let me just solve it and then we can verify whether it's correct or not. This is the AC. This AC has been given to you equal to BC, right?
Hmm.
Means ABC is an isosceles triangle, so their angles opposite to the equal sides must also be equal.
Hmm.
That means we can assume this angle to be 40 degree.
Oh, I thought
This is
the
just
80 was only part of it.
no 80 is just this much has been drawn over here.
Oh,
Okay, no problem. I'll just do it here. After that, even this angle can be assumed to be 40 degree only because 80 plus 80, like 40 plus 40 is 80 only. We need to get this x. Okay, there are two ways. One is a little longer way, but I think, yeah, you can even do it using a shorter way. Let's do one thing. We'll just get this side. It's just marked with the slash in the first upper triangle, in triangle BCD. In triangle BCD, we have two angles, angle C and angle B, as you notice at the top. And okay, we need to get actually, if you only note, okay, I'll just extract the triangle from the top. So this is the triangle we have. This is, if you only focus on this triangle, this is my C, D, B. This is obviously small d then. It's opposite to that. This is given to you as 30 degree. This is what is useful actually. We only anyhow we wanna get this d. If we can get this, this will also be equal to AC, and then we'll be able to get x easily in the triangle. Or even directly we can get that. Well, it's okay. This is d. That's what we have to figure out in this. And this is 3 centimeter, which is what? Which is small c, you can assume. So we need to deal with d and c. But the angle given to you are B and C, so it's first of all do one thing, let's get the value of angle D. Angle D we get as 70 is 110 degree. Using angle sum theorem, right?
hmm.
180 negative 30 negative 40 is 110. Now we can take C because we want to get D and other side is C, so C and D will work. So we can only take these two according to the sine rule. We modify the rule like symbols accordingly. We can write small c over sine of angle C is equal to small d over sine of angle D. Is that okay?
Hmm.
We can also write B over sine B, but that's not useful, so we just don't write it now. C is 3, and angle C is 30 degree. D we don't know. And D, this angle D is 110. We transform the terms from one side to the other. So 3 times sine 110 degree over sine 30 degree. When you bring sine 110 to the other side, it goes in multiplication with 3, and sine 30 is at the denominator. We first of all solve for D. 3 times sine 110 over this. It gives you 5.63, let's say 5.6 centimeter. That's the value of D. Now half of the question is done. So this came as 5.6 centimeter. Once we got this, either we get this angle and then we apply with that, or even if this is 5.6 centimeter, this is also 5.6 centimeter. So that we have angle A and B. Otherwise we would have got angle C from there. But it's okay, let's consider in this way and take another triangle ACB this time. We take the triangle ACB. like this. Triangle A, is it A? No, it's C. Okay, C, A, B. These two sides are given to you equal, and we need this 5.6.
Hmm.
Even this is given to you as 5.6, or we don't need this time. We just write it as it is. Angles are 40 and this. Okay, x has to be obtained. Well, it's not needed to even write this thing. That's okay. 5.6 centimeter is fine. So we don't write it. Even if you write, there is no problem. 5.6 centimeter. We have, this is called small a this time here. And we have x centimeter here. That will be called as a small c. So which two angles we need? Can you tell by these two, see by seeing these two things, which two angles we need?
We need angle A and C.
Correct. Angle A is needed and angle C is needed, which is not given to you but can be easily obtained because this is also 40 degree. So that is 100 degree. And that's okay then. We can apply A and C we have to take. So again by sine rule, we apply A over sine A is equal to C over sine C. Small a is 5.6. Sine of angle A is 40. C we have to figure out, that is x. Angle C is 100 degree. Let us transform the term from one side to the other. The sine 100 degree is multiplied to 5.6 and sine 40 is in the divisor. That's about 8.57 actually. 8.57, so about 8.6 centimeter is the answer.
Hmm.
Yes. Alright, so you now go through this question and tell if you have any doubt in this.
No.
Okay, just 1 second, my battery of my headset is little low. I'll connect the charger to it. Just 1 second. Okay, it's connected now.
Hmm.
So, alright, this is how we got this thing, and after that, okay, we generally have this kind of questions, and now move on to another example where they give the two both the two sides and they give you only one angle. So in that cases you have to still apply the sine rule only. The last thing you need to do is you need to transform the term from one side to the other and get the value of theta or angle, whichever is missing.
Hmm.
So I'll show you one of the question like that. One sec. Simple question. Similar thing is there. Like this is, suppose you have A, B, C. So sides which we have to deal with are small a and small b. So we are given both the angles. There is no, actually we haven't been given, but we need to deal with that. We need to apply that into the formula. So that's perfect. So by sine rule, we can apply the same formula is equal to b over sine b. A is what? A is 5. Angle A is 20. Side B this time is given, and even this angle B hasn't been given. It's theta actually. So we keep it as it is. Okay, so we first transform the terms. Let's say sine 8 comes here together with 5. Sine theta is together with 5. And we cross multiply it. So it's finally 8 times sine 20 degree over 5. When you simplify this expression, let's see what we get. We get about 0.547 something. That's not your answer actually. Why? Because we have been asked to get theta, not of sine theta. So once we have this thing, let me write down. We are given sine theta, we found as 0.547. So when you want to get the value of theta, you bring the sine to the other side. So it's treated as sine inverse. Sine inverse, and whichever is there, that comes in this argument. And this you can use now. Even in the calculator, we have this function of sine. If you click the shift key and then you press the sine button, it will appear as sine inverse. And when you put these values, it gives you about 33.16, approximately 33.2 degree. That's your final answer. Yeah. This symbol is for approximately equal. So you can apply that, or even you can apply the equal sign. That's also okay. Still, if you have any doubt in the question,
No.
would you like to do a question like this?
Yeah.
Okay. This one you may try.
Uh, 69.75.
Yes, that's correct. But that's what I also have got. Okay. Let's now have a little. 1 second. A question like this, just like we did earlier. We have a compound figure. This time that symbol means this is 30 degree, this is 40 degree separately. The total is 70 degree, right? We want to get theta. If you notice the upper triangle, two angles we need to deal with. If this side was given to you, you could have easily found, you could have applied the sine rule in that. But if they haven't given, you are still given some idea to get that. And this time it's good that it's a right angle. Okay, so let's now do one thing. We've done trigonometry for right triangles. Let us verify that as well as the sine rule in this question, because at the bottom we've got the right triangle. This rule is applicable on right triangle as well as on non-right triangles. So I'll do one thing. I'll draw the diagram twice in this. And let's now try to get this side using both the methods, the earlier method, though it's not needed to do, just to verify, just to understand. I'm going to do, we're going to take the triangle ABC. Say this is the triangle. 1 second. Okay, that's how the triangle are given. Like the same triangle is there. We are going to apply two methods. The one method is simple, that we used to learn earlier, where we have one right angle. So we can apply any of those six trigonometrical ratios. That's useful. So the angle is given to you as 40 degree, and one other side is opposite to that. This is 7 centimeter, and you need to get this x AC. Let's say this is x. We consider that to be x. That's what we have to figure out. So actually this time we have to deal with opposite and adjacent, right? So we can apply tan theta. If you remember, we used to learn tan theta equals TOA. SOHCAHTOA, according to SOHCAHTOA, it's opposite over adjacent. So tan 40 degree equal to opposite is 7, this is x. X equals 7 over tan 40 degree. 8.34, say 8.3 centimeter. Now let's apply the rule that we are learning right now. You can still apply that because the given one has the angle here, that is 40 degree. This is 7 centimeter given to you. So we have to deal with the side A according to the sine rule and the side B. So first of all we need the angle B at least here. That can be obtained easily. 90 plus 40 is 130, and if you subtract it from 180 you get 150 degree. Yeah. So now we can apply the sine rule. According to the sine rule we have A over sine A is equal to B over sine B. If small a is 7, angle A is 40 degree, B we have to get, and this is 50 degree. X is equal to 7 times sine 50. So now let us put this thing into the calculator. I'm going to put that thing into the calculator, and definitely that will be equal to 8.3 only. You can also check at your end if you want. 8.34, yeah, the same thing we get here also. 8.3 centimeter. Means both the rules are applicable. Like this rule basically, sine rule is applicable either on right triangle or even on right triangle. Once we got this x, half of the work is done. X we got as 8.3 centimeter. Now we may take the upper triangle ADC. This is the triangle ADC. This angle is theta. This one, yeah, never mind, that's not the theta. This angle has to be figured out. This is theta, and this is 30 degree at the bottom. Now you have two sides. 8.3, this is 8.3 centimeter, and this side is given to you as 6 centimeter. Now both of them are given, like we have to deal with A and D. So small a and small d both are given, and we are good to go then. You can again apply the sine rule. A over sine A is equal to, this time it's D, so make sure to change the symbols. Angle A is 30 degree, and okay, D is 8.3. Angle D we don't know, that is theta this time. Okay. We then cross multiply, we transform the terms, so we finally get 8.3 times sine 30 over over what? 6. Yeah, 6 goes into division. Now we use the calculator to get that. We get 0.69166666 like this. 1 second. 0.691666 recurring, so let's say 692. And the last thing you need to do is to bring sine to the other side. That becomes 0. Sine inverse of this value. And we may again use the calculator. It gives you about 43.78. So approximately it is 43.8 degrees. That's your answer. Yes, Maya. Now tell me if you have any doubt in the question. This is actually this thing wasn't needed actually. Either one of them you could have applied. Just because we are learning sine rule, so we would have preferred this thing. But it's still okay if you apply this, if you get a right triangle. So only one of the column you should use. But the second thing for the upper triangle we have to do in this way only. That's the only way. That's all about the sine rule. I hope you must have understood.
Yeah.
Now we have another rule called cosine rule. So the cosine rule is again uh, applicable on both either right triangles or even on non-right triangle. But sometimes it may be possible that we might not apply sine rule in certain questions. In that type of questions, we have to apply cosine rule. First, let's see in which all are the questions where we can't apply that. Let's say you have a triangle. This is A, B, C. You are given this is 7, this is 3, and this is 9. Nothing is given to you apart from that. They asked you to get the angle A. Is it possible to use this sine rule to get the angle A now in this?
No.
Yeah, because at least one angle should have been given in order to apply the sine rule. But right now that's not given. That's why we need another method that's called cosine rule. Though they given the formula directly here, it might be difficult to memorize. So I'll tell you a simple way to memorize the formula. It's not only the single formula, we can have 3 formula for that. Triangle is still similar, like opposite side of angle A is a small a, angle B is a small b, and angle C is small c. Okay, so again, let's suppose you have a triangle ABC. And these are the sides ABC. So let's say you want to get angle A anyhow. You need to get the angle A. So you will write down cos A. I'm just telling you a trick so that you can memorize the formula. Cos A is equal to, now you write those two sides, square of those two sides which are other than that A. So that are B and C, right? So B squared plus C squared. And then subtract corresponding to that angle. Side which is corresponding to that angle, which is A. Okay? And at the bottom you write 2 times of these two sides only, not the third side. So this is for if you want to get the cos A. But let's say you want to get angle B or cos B, in fact. Okay, I'll just also tell you how to get this form. I think it's really easy to transform that. But initially I'm telling you, suppose this is the main thing to get. If you want to get cos A, you can do this way. Now say if you want to get cos B, then what to do? Suppose this time we have cos B. Let's say this is the angle, a different angle we have. And we want to get cos B. So again, by symmetricity, what we did in the previous formula, we do the same thing. We can assume the two sides which are other than B, which are C and A this time. And then you subtract the square of corresponding side. And then at the bottom you write 2 times CA of these two other sides. Just like here, similar thing is here. Now even for angle C, if you want cos C, you can do the similar thing. Suppose we've taken angle B this time. Let's talk about angle C. This is the angle C. So you want to get cos of angle C. So can you tell me the formula now in the similar manner?
A square plus B square minus C
Right?
square over
Correct.
2AC, AB.
2AB. Correct. Very good. These are the three formula. So sometimes they might ask you the angle, so you do it in this way, and at the end you bring cos to the other side, so it becomes cos inverse, and you get that. But sometimes even it may also possible that they give you the angle, and one of the side is missing. So let's say you want to get A. So for that reason, what you do, you transform that 2BC comes to this side in multiplication. 2BC times cos A is equal to this RHS. Now you bring A square to that side, and you bring this entire term to the other side. So that becomes negative. Also, it's still not done because it's A squared. You want to get A, so you will get the square root of both the sides. So particularly for getting A on the side, you can directly apply. If you don't want to memorize this thing, you can either memorize this, but I would suggest you to just learn how to frame the formula. That would be much easier. And whenever you want, you can derive. You can just get the formula and get the result whichever is needed. So
Hmm.
either this or at the top, whatever is there, whatever is you like, you can memorize. Similarly, these two can also be used to get side B and C. I think I don't need to write that. You understand how to transform the term from one side to the other.
Hmm.
Okay, let's practice some question now. Sometimes they might ask you that angle may be missing, but even may possible that they give you the angle and one of the side is missing. First, let's see this question. Okay, initially you might not understand whether it can be solved with this sine rule or cosine rule. So what do you think? If you want to apply sine rule, is can that be applied this time in that? It may also,
No, I don't think so.
yeah, but sometimes it may also possible that both the rules may be applied. So it depends. Like right now, it can't be applied. Sine rule can't be applied, but there are certain ways in which we can apply them. We'll say this is A, B, C, and I even haven't memorized that formula yet. The bottom one, I only remember this thing, and I just do transformation within the question. So angle A is given, so I write this formula for cos A. Why? This is called cosine rule, by the way. Cos or cosine are the same thing. Cos is the
Hmm.
shortened form. So by cosine rule, we have cos A equals what? B squared plus C squared negative A squared over 2BC. To B, it's this is B, this is A, C. 3 squared plus 2 squared. Sometimes we may even come across a quadratic equation in that type of questions. We'll see some of the examples later. So that's also easy, there is no problem. We solve them as per the rules. 3, 2, this is angle A, which is 140 degree. So 9 and 4 are 13. 13 negative x squared over 12. Cos 140, we write the value. Negative 0.766. Now 12 goes into multiplication. So I'm directly writing 0.766 times 12 is 9.192 with the negative sign. I multiplied that. Now x square comes to this side, it becomes positive, even this goes to the other side. 13 plus 9.192, 22.192. So you get the square root of that. It's about 4.71, 4.7 meters. That's the answer.
Hmm.
Okay. Any doubt in the question?
No.
Okay then, let's practice one question. I think you can try. I'll give you another question. 1 second. Okay, let's get the angle this time. They haven't given the angle in the question. You have to do the same thing exactly. At the end, you bring cos to the other side. I'll show you the question.
This one.
94 you get. Yes, approximately that. About 95. If you're around 94.9 I got. If I just
Yeah,
go with one decimal
94.9.
point. Yeah. Okay, no problem. That's correct. So that's how you simply apply the cosine rule. One other side. So you see one thing, like if three sides and one angle you have to deal with is a cosine rule. And when there are two sides and two angles to deal with, then you apply the sine rule. That thing you can keep in your mind.